Hi, this is Daniel from Daniel JR Game Art. Today I'd like to make a quick presentation of 8 exercises based on 8 aircraft parts. The original models have been designed and modeled by Andrew Hodgson. He's a great 3D artist working at ILM Vancouver. You can check out his art station, the link is in the description. He did the parts with Maya, so it's real geometry with polygons and subdivisions. I wanted to study art surface techniques within Substance Designer, so that means faking art surface objects with textures. Obviously, it's a very different approach from traditional 3D modeling, but there are similarities, and I saw in Andrew's work a good way to train myself. It was a good challenge, and I did the 8 parts as close as I could. So let's begin by looking at Andrew's work. So now let me show you the result of my work on this topic. Before we dive into the techniques used to build these substances, I'd like to talk about height maps and normal maps. The good thing with Substance Designer is that you can have a decent displacement render even with a low-res mesh, as long as you're rendering with the default OpenGL renderer. For example, let's choose a basic cube, then a rounded cube, then the high-res plane. In this last one, the geometry is heavily subdivided. But the displacement render doesn't change, so the OpenGL render works really well. Just leave out of the height map any detail that doesn't need to be elevated above the surface of the object. In this example, I left out of the height map those little circles. Having them only in the normal map is perfectly fine. Now, if we switch to Array or Marmoset toolbag, the lower the polygon count of your 3D mesh, the lower the quality of the displacement and the less displacement effect you'll get. Let's see that with Array. First, with the classic cube, we know that the subdivision level of this one is very low, so we get no displacement effect. The rounded cube has more geometry, but as you can see, the displacement is really bad. So let's try with the high-res plane now. It's a bit better regarding the main general form, even though the diagonals are ugly and the small details are just horrible. It's the same thing with Marmoset toolbag. I tried it, and also with other game engines. So I would personally avoid height maps for hard surface in real-time rendering projects, but for organic subjects, and as long as the height map is carefully blurred and treated, you can use them. Otherwise, just stick with normal maps. So for now, I'll keep the height map out of the scope of these exercises and will rely only on normal maps. That's all I wanted to say about the displacement issue. This is a game art channel, and I know that displacement is not often used in games. The need for high polygon counts in the meshes can cause performance issues. So games rely on normal maps and low poly geometry to get the relief the surfaces need. With the first exercise, we can have a look at the main shape. I always start with that, even though making small details is generally easier. So I started with the tilt here. I just blended a rectangular shape with a gradient. Of course, I used the multiply blending mode to get the effect. Then I transformed its orientation and added it to the main big rectangle. Then it was time to cut out secondary shapes in the lower left part here by creating a mask that is subtracted from the main shape. Same thing here with the right part, and that's all. Our main shape is ready. We can now add our first detail, the paint shape. As you can see, I used the max lighten blending mode to add it. I just corrected the gray value to make sure that the added part appears. Because if I don't correct the value, here's what happens. We don't see anything. So working with your values is very important to make sure everything is clearly visible. So the paint shape now, as you can see, I named it hockey stick. I started by making the curvature, the angle. This quarter circle is obtained by playing with the cropping area of the blend node. Then I subtracted from it a smaller circle. I continued by adding horizontal and vertical bars of the same width. A light bevel effect and a curve node were added to polish the look of the hockey stick. Lastly, the transform node is needed to position this part precisely where it needs to be. Now maybe we can have a look at the hollowed out circles here. There are two parts. First, making the concentric circles, then duplicating them and placing them. As a subtract will be used to insert the detail into the main object, the darker a circle is, the less depth it will get. So as we make our way to the central lighter circle, we know it will be lower below the surface. So I just made circles of various diameters and combined them together. The second part, as I mentioned, consisted of duplicating one and then positioning both of them with transform 2D nodes. I then subtracted them from the main surface. You can play with the opacity level to change the effect like this. That's it for part number 1. Part number 2 now. For this one, I'd like to talk about this inset, this arc inset as I named it. I took some time to figure out how to do that. So let's look at the original one. So I just used the base shape, duplicated it, reduced the size a bit and keeping the duplicate centered in the frame. Then 2 curve nodes to get a solid white color. Then this shape stroke grayscale traces the contour and render a thin line out of it. I blended the two. Here a splatter circular renders a radiation of lines. And with this random mask of 0.08 value and a blend, we get this. I also cropped the right side to make it cleaner. We're not there yet, so I needed something else. I guess one could say I cheated a bit for this one as I used the SVG node. In other words, I drew a mask by hand to keep only what's needed to be kept, this area here. Then I just subtracted the lines from the main shape. And the mask helped me make sure the subtraction was restricted to the required zone. And we have it. It was a bit tricky, but as always, the discussion is open. If you have a better idea for doing this, you can share it. Now some words about the tabs. There's not much to say about the tabs in themselves. It's their blending with the big main shape that's interesting. So you have this tilt here at the back or at the right of the shape. And in order to add the tabs, I had to use a copy blending mode or a multiply and a mask to display only the tabs. If you use the max lighten in such a case, you'll get almost nothing, as you can see. Even by using a levels node to correct the values, we don't get exactly what we need. So the best course of action here is to use a mask. To create it, I started with a histogram scan to get a solid white. The edge detect here was useful to give me some control over the mask size. A blur with a small intensity, and a transformation 2D just to fine-tune the positioning. The edge detect, as you can see, helps me in getting control over the mask's border thickness. The number 3 was probably the easiest one to do in this series of exercises. Like with part number 1, here the piece also has a tilt. So it was just a matter of combining the gradient here with the rectangular main shape. Once again, I used the cropping feature of the blend node to crop the bottom of the rectangle. This way the gradient appears fully. The rest of this piece was easy. It was just small details to add. Let's move on to exercise 4 now. This fourth one seems quite easy, but there was at least one difficulty. We can clearly distinguish different angles in the main form. We have narrow 90 degrees angles and one wider, smoother one here. So before I applied the blur, here's what I had. The 90 degrees angles are easy to get. But how did I get this one? Simply put, by subtracting a sphere from a rectangle and adding it to the vertical rectangle, like this. Then I added the horizontal one. The blur gave me the bevel. But I also wanted to have a clean delimitation of the main shape. You can see the difference here. In order to get that, the histogram scan is very useful. It gives us a solid white color, and if you adjust the contrast well enough, you end up with a good mask. Slightly smaller in size than the main shape. And that acts as a cutting tool once plugged into the opacity of the blend node. That gives us a clean border for the object. When you want to produce art-face content, cleanliness and sharpness are good constraints to follow. What can be said about part 5? The rounded nicks, as I called them, are worth talking about. The difficulty here is to have a good thickness for them without compromising the form. Let me show you why. I think you get what's happening. If I want good horizontal lines, I have to reduce the thickness of the nicks. Of course, it's due to the way I constructed those shapes. I simply put together rectangular shapes, then blurred them pretty heavily and trimmed them with a histogram scan. Maybe not the best way to do it, but surely one of the easiest and fastest. The end result is good enough for me. Let's have a look at the original object to see if we are really off or not. We could have more length and width. Modifying the length is easy. You just play with the X value in the shape nodes. To have more thickness, you need to reduce the blur effect and increase the position in the histogram scan node. Unfortunately, by doing so, we lose the rounded tips. So I go back to the previous settings. That's all for part number 5. Let's move on to part 6. This one was really easy, so I have nothing to add. Let's skip it and go straight to the number 7. We have a complex shape here. It's a combination of sharp, hard angles and a very wide and smooth one. So I'll walk you through the making of it. I won't talk much for this part, I'll just show you the graph step by step. Okay, I think we're done with this one. Let's finish the video with the part number 8. Okay, so for this one, I'll just talk about the bevel node a little more. It's a very good and fast way to produce a tilt. You can choose the distance, the corner type. In this case, the bevel node helped me a lot. Then I just had to cut off what I didn't need with a blend node. The histogram scan technique was used to produce a mask, which allowed me to get a clean delimitation for the object. Then I kept building the base structure. I'm going to finish the video by showing you how I built this piece here. It looks like a fan. The main question, of course, is how to position a similar part on 3 different places at equidistance. I used a helper, a guide. I simply superimposed a triangle above the circular shape I used to build the fan piece. Then let me show you what you can do with that. It's a simple and a pretty useful technique if you want to avoid calculations. You could also use a splatter circle, I think. It should work. But I like the visual positioning, it's fun to do. Now I'll show you the rest of the fan building process. This walkthrough is now finished. As a conclusion, I would say that the main difficulties in doing this kind of work reside in the making of the main base shapes. On the other hand, most of the small details are easy to do, although a tiny part of them are a bit tricky to execute, like the fan thing we've just covered. Now let's have a quick look at the output maps. This is the metallic, the opacity, and the ambient occlusion. I had a very good time making the parts, the exercises. I also saw them as a good preparation for what's coming next, several hard surface projects. Still in Substance Designer. Thank you for your support and comments. Work smart, play well, see you soon.